Figure A shows object A, B and C connected by a thread with a force of magnitude F acting horizontally on C. This causes A, B and C to move uniformly accelerated motion with their speed increasing. Figure B illustrates the moment when the thread connecting B and C breaks as B reaches velocity v. From the moment the thread breaks until B comes to rest, A, B and C each undergo uniformly accelerated motion, traveling distance of d and 4d respectively. The magnitude of A's acceleration in figure B is twice that in figure A. The mass of B and C are m and 3m respectively. Based on a scenario only, the correct options are to be selected from the given option, and the assumptions are that the acceleration due to gravity is g, all objects move within the same vertical plane, the size of the object and the mass of the thread, air resistance, all friction are neglected. So there are three options. At the moment B stops in figure B, the velocity of C is 3v. Option B, the mass of A is 3m and the applied force F is 5mg. So these are two figures. So this is figure A and this is figure B. So in figure A, a force F is being applied so that the entire system of A, B and C moves all together. And figure B, the thread breaks. So because of this A and B moves in the opposite direction to the initial acceleration, and B moves by a distance d, as well as A also moves by a distance d, and the C moves by a distance of 4d. So these are information given to us, and we are supposed to find out which of these three options A, B and C are true. So let us start with try to find out the solution for option A. And it is given that A, B and C, let us suppose all are moving with velocity v and acceleration A. A, B and C, and this is before thread breaks. Before thread breaks. So we say A, B, C moves with velocity v and acceleration A. And after string breaks, thread breaks, after string breaks, it is given that distance traveled by B is d and distance traveled by C is 4d. Distance traveled by B is d and by C is 4d. So we can find out, and it is also given that the velocity of C after the string breaks at a particular point is given as vc when the distance is 4d. So here the velocity of C is given as 4c. You can write, and it means velocity of C is vc. It is given to us. We can write the average velocity of B average velocity of B, Let us call that as VB bar will be equal to V plus 0 divided by 2, which comes as V by 2. And similarly, we can, for C, we can write it VC bar, and that will be equal to V plus VC divided by 2. And the ratio of the average velocity is proportional to their respective distances. This is formula we already know. We can write that ratio of the average velocity is proportional to their respective distances. To their respective distance. To the respective distance traveled. Distance traveled. So therefore, we can write that our VB bar upon VC bar will be equal to D by 4D, which comes as 1 by 4. And we substitute the value of the average formulas which we just calculated. It is V by 2, and here we have V plus VC, and this y by 2 is equal to 1 by 4. 2 cancel with 2, and therefore we can write that this gives us that our V plus VC will be equal to 4 times V. So from here we can say that our VC is equal to 4V minus V, and this comes equal to 3V. So therefore we can say VC is equal to 3 times V. So option number A is true. So this is our true. Option A is true. Now we are supposed to find out the respective, you can say, acceleration, mass of A. And for that we are going to use equation for kinematics. Equation of kinematics. We start with, first of all, for B, and the equation of kinematics we are going to use, it is our V square is equal to U square plus 2AS. So for B we can write this as VB square is equal to UB square plus 2 acceleration of B multiplied by distance traveled by B. We substitute the respective values. VB, that is our final velocity for block B, is 0. So VB is equal to 0. UB is our V, and distance SP traveled is given as D. So we substitute the value. We get 0 is equal to V square plus 2AB multiplied by D. So this gives us the acceleration of B is equal to minus V square upon 2D. Now we are going to use equation for kinematics for you can say our B also, block C now. So you can say for C, we can write VC square is equal to UC square plus 2AC and SC, distance traveled by C. And we know that our initial velocity of C is V, final velocity of C is our VC, and distance traveled by C is our 4 times D. We substitute it here, we get this as, and VC just we calculated is our 3V. So let me write it here, is our 3V. So we substitute, we get this as 3V whole square is equal to V square plus 2AC and multiply by 4D. So this comes as 9V square minus V square is equal to, this will be over 8AC multiplied by D. And this also comes as 8V square, and 8 cancels out. Let me write it here. This comes as 8V square is equal to 8 acceleration of C multiplied by distance D, and A cancels out. So this gives us that our acceleration of C is equal to V square by D. So we found out the relationship between the acceleration of A and B respectively with the velocity V as well as distance D. Now we find out the ratio of AB by AC, and we are only considering here the magnitudes. Okay. So we can say that AB upon AC will be equal to, this we have V square upon 2D, and we have V square upon D, which comes as 1 by 2. This gives us that AC is equal to twice of AB. So we got the relationship between the acceleration of block C as with the acceleration of block B. And we assumed that the acceleration of A before the string breaks is A. So we said that acceleration of A before string breaks is taken as A, and according to the question, that after string breaks the acceleration is twice. So we can say after string breaks the acceleration of A will be equal to 2A, but the direction will be opposite. Okay. So initially they were traveling in this direction with the acceleration of A, but later on it is traveling in opposite direction, which is twice of A, and obviously it will be negative. So we can write this as minus of A, and A and B are connected together, so therefore acceleration of B will be also equal to minus of 2A, as A and B are connected together, therefore acceleration of B will be also equal to minus of 2A, and this gives us that, let me consider a minus sign, it will be much more convenient later on. Therefore I can say that the acceleration of C will be equal to minus 2A multiplied by 2. So this comes as acceleration of C is equal to 4 times A. So we found out the acceleration of A, B and C in terms of the initial acceleration. Now let's find out what will be the change of acceleration for C and the change of acceleration of A plus B, because A and B will be moving together. We say change in acceleration, change in acceleration for, let us do it for first C, and for C we can write this as 4A minus of A, which will be coming as 3A, and for A plus B, as they are moving together, we can write this will be our A minus of 2A, and this will be also equal to 3A. So let us call this as 1 and this is called as 2. I think not used 1 and 2. Yeah. So from 1 and 2 we can see that the respective change in acceleration in both the cases for A as well as A plus B is same. We can say change in acceleration for C is equal to change in acceleration for A plus B, because A plus B are moving together. So we can say that is change in acceleration if we represent as in terms of delta. So change in acceleration, let us suppose that is delta A. Here let us say this is our delta AC and this is delta of A plus B. So we can write that our delta of AC is equal to delta of A plus B, and let us assume that this is equal to delta of A. So therefore, this minor change in acceleration delta of A, let us suppose, is because of the change in the force, that is delta F. You see this change in acceleration, that is our delta A, is due to change in force and let us call that force as delta F, because as the thread snaps all of a sudden there will be a change in the force, that will be delta F, and that will be resulting in change in acceleration, that is our delta A. And this change in acceleration for both for C and A plus B will be same, which we just proved out. So therefore we can write the formula that change in force for A plus B will be equal to its change in acceleration for A plus B and divided by mass of A and mass of B. Mass of B is given as M and mass of A is our MA. And delta of AB, A plus B, we have just said, let us suppose that is equal to A. So this is equal to MA plus MA plus M, where MA is mass of A, which we are supposed to find out, and M is mass of B. It is given. Similarly, we can write that change in force for C will be equal to delta AC and divided by m. Mass is given as 3m, which we can write as delta A upon 3m. So therefore, we have two equations, and we just said that the change in acceleration will be same. So obviously, this change in acceleration will be because of the same change in force, that is our delta F as well as delta C. So you can say as the change in acceleration for C and A plus B is same, the change in force for C and A plus B should also be same. Should also be same. So therefore, from here we can write that delta F for A plus B will be equal to delta F for C. We substitute the value is our delta A upon MA plus M is equal to delta A 3 times M. Now it is quite simple. This gives us that our MA plus M is equal to 3M, and which tells us that mass of A will be equal to 2 times M. So this is mass of A. This is mass of A. So the options that are given to us, the option states that mass of A is 3m, so this is false. So option B is false. Option B is false. And let us find out value of force now. So before string breaks, let me draw a rough approximate figure. So the system is like this. We have a pulley here, and with the string, this is B, and we have this is C. Force F is being applied, and here we have block A, and the entire body is moving with the acceleration A towards the right side, and in the downward direction we are going to have a force that is our MA multiplied by G. So we can write the equation of motion that F minus MA G will be equal to MA plus M plus 3M multiplied by A. We already know the value of mass of A, so we substitute here. We get this as FA minus MA is our 2M multiplied by G, and this is our 2M plus M 3M multiplied by A, and this comes as 6MA. So we get the equation as F minus 2mg is equal to 6 times MA, and this is before the string breaks. And after the string break, after string breaks, the force F is only with respect to block C. So this is our block C, and force is applicable only on this block C, and we assume that its acceleration is AC towards right side because the force is being applied. Therefore, we can write the equation that F for block C, we can write that our F is equal to, mass is given as 3m multiplied by AC, and we know the relationship between AC and acceleration of A. So we write that our F is equal to 3m multiplied by 4 times A, and this comes as 12 ma. Now we have two equations, that F is equal to 12 ma, and from here let us find out what will be value of ma. Ma will be F upon 12, and we also found out that our F is F minus 2 mg is equal to 6 times ma. So let me write this equation here. F minus 2 mg is equal to 6 ma. 6 ma. We substitute the value of ma. We just found it here. 6 multiplied by F upon 12. 6 goes with this 2, and we are left with this as F upon 2. Oh, that is a simple calculation. We can write F minus F by 2 is equal to 2 mg, and this gives us that F by 2 is equal to twice of mg. Therefore, the applied force F is equal to 4 times mg. So this is the value of F, and we check the options that are given to us. The options states that F is equal to 5 mg. So this option is also false. So we can say that option C is false. Option C is false. So this completes the question. Thank you.